Do a run through of how to factor a trinomial into its binomial factors. Some people call it reverse foiling because basically when you FOIL you multiply two binomials and end up with a quadratic trinomial or otherwise. But in this case we're going to factor a trinomial into its binomial factors. We will begin with a basic binomial. I'm going to make sure I'm in black here so we can see this clearly. We've got x squared plus 7x plus 12. Now, in this case, we're looking at positive 7x and positive 12, so we know that, and we're also looking at a coefficient of our squared term of 1. So this one is really very straightforward, but it gives you a sense of how to do this. I usually, when I'm teaching this to beginners, start by setting up a series of parentheses. 4 is often a good start. Now, we know that the first term is x squared, and since there's only one way to build an x squared, by multiplying an x by an x, I'm going to go ahead and fill those in, because I know that the factored form of this trinomial is going to begin with x. Now I also know that because I'm trying to build a positive 12 with this last term multiplied by this last term, that both this sign here and this sign here need to be the same. They could potentially both be negative because a negative times a negative is a positive. But as you know, when we FOIL, we combine those middle two terms, the O and the I, the outside and the inside. If those two are the same signs and they combine to make a positive term, these signs both need to be positive. So I already know a good deal about my factored trinomial. It would begin with x and then it followed by a plus. Now the only thing I need to decide is which of the factors of 12 I'm going to use. Now you may have already figured this out, but there's 6 different potentials, although in this case it's really only 3. We've got 1 times 12, or 12 times 1, and this will come up later when the coefficients of the leading term are not 1. We've got 3 times 4, and we've got 6 times 2, or 2 times 6. Now, I'm going to go ahead and fill those in, because I'm going to pretend I really have no idea. Okay. And I should have done 2 and 6 there, but just to keep it consistent with the smaller of the two. The key to factoring trinomials, in my opinion, is to make sure you approach the problem with a systematic attitude. So you eliminate, you don't end up doubling up on trying, because there is some trial and error. So let's check this out. Now we know that x times x is x squared. And we know that 1 times 12 is 12. So we know about f, and we know about L. What we're wondering about is this O and the I, the outside term and the inside term. Now, x times 12 is 12x. X times 1 is 1x, and 1x plus 12x is 13x. We're not looking for a 13x, we're looking for a 7x, so guess what? Not it. Okay? Moving on down, we know that x times x is x squared, and we know that 3 times 4 is 12. We do that right at the beginning. So now we really are only interested in the middle terms and how they combine. So x times 4 is 4x, and 3 times x is 3x. 4x and 3x is 7x. So guess what? I have found it. Okay? Now again, that one was fairly straightforward. But let's look at another one with a little difference. We've got, let's say we have x squared minus 10x, come on, plus 16. Now again, I would set this up as a series of parentheses because I want to take a systematic approach. If I'm not seeing it right out of the gate, I need to make sure I find it, and I'm going to search for it carefully rather than just willy-nilly. Okay? Again, my first term is an x squared, a 1x squared. So I know that the first term of the binomials is going to be x. Okay? Now, looking at the last term, 16. A positive term means that this term multiplied by this term have to be positive, which means one thing. Either both signs need to be positive or both signs need to be negative. Now, so how do I decide? Well, that's when I look at the middle term. The middle term is negative 10x. If the two terms that are both the same sign end up combining, my O and my I end up combining to build a negative middle term, then I know right out of the gate that these two signs have to be negative. Because I can't build a negative 10x with two positive terms. So now again, I'm looking at how do I build a 16 with two terms multiplied together. Now I could do 1 times 16, I could do 2 times 8, I can do 4 times 4. Okay? I don't think there's any other factors of 16. So we can go ahead and look. 1, 16, 2, 8, and 4, and 4. Now, again, because this leading term is a 1, the x and the x are x. It's not 2x and x. We'll get to that in a minute. Whether I put the 1 first or the 16 first, which order they go in doesn't make any difference. It will come into play in a little bit, and you'll see that. Again, x times x is x squared. We know that our first terms multiply to be x squared in every one of those situations. We also know that our last term multiply together. Negative 1 times negative 16 is 16. Negative 2 times negative 8 is 16. Negative 4 times negative 4 is 16. We know about the last term. There's no point in foiling out the whole thing. We really only need to look at how our O and our I, our outsides and our insides, go together to build that middle term. So we've got x times negative 16, which is negative 16x, and negative 1 times x, which is negative x. Those two combine to be a negative 17x. Not it. Oops. Okay. Our next one, we have x times negative 8 is negative 8x, and negative 2 times x is negative 2x, and a negative 8x and a negative 2x combine to be a negative 10x. Wow, I found it again. Excellent. Okay, so I don't even need to go here. Okay, that's it. It's x minus 2 times x minus 8. Okay. Now, let's look at a situation where the leading term is not, if my thing doesn't freeze up here, is not a 1. Actually,